Okay, so let's continue our lecture. I don't have my microphone now, but I think it's okay because I have a big voice myself, I guess. Last time I went to a conference for teach professors how to teach. Okay, so the lecturer told us that the first factors that make you a good teacher, the first one is you have a really big voice. So it will make it will make all the students in the classroom can hear you. That's the essential thing. So I guess it's okay. 听懂吗？就之前我参加一个研讨会，就是教你怎么样去教学生，教课。他说第一个让你当成一个好老师的第一个要点就是你的声音要大。首先你要声音要大，这样才能让全班的人听得到，然后大家才可以知道你在讲什么。那我觉得 OK 啊，我声音很大。可是年轻的时候上3个小时用这样的声音可以，但是老了以后就不行了。哦，那个声音就是一直能量输出，哦，实际上是蛮辛苦的。OK，好，那我们就开始吧。So yeah, last time we talked about yesterday we talked about the most important thing was what was that? Okay, the most classic examples, right? The biggest classic examples that you're going to do the chapter 4 to get the shear and moment diagram. And then you need to find the example asks you to determine the maxima tensile, maxima compression stress. So because you analyze this formula, you see M, Y, I, the three factors. Y are kind of fixed, C1, C2. I is fixed because they share the same cross section. So the only thing is that the M. Okay, so M positive and negative, the biggest and negative, the most positive and most negative M is are possible to generate the highest, the maxima stress. Okay, so the first one is getting M pulse and N negative. And then we need to examine or analyze the cross section. The cross section, first one, you need to get the neutral axis. And a tip I introduce here is that just put your starting point, O1, at the top. And then if once you determine the coordinate of the of the O, which is neutral axis, and you immediately get C1 is 18.48. And then you got C2 immediately as well. So neutral axis done, and then you need to calculate moment of inertia. Okay, so you see there are 3 areas, but the areas all rotate about the neutral axis. So you need to move this area's axis, central axis, to the real rotational axis. So there are three times of parallel axis theorem. Okay, you move from here to the pink one, and you move from here to move to pink one. Okay, so and then adding up together, you have the entire the moment of inertia for entire cross section, and then you have IZ. Okay, and then you need to examine the M positive compression and tensile, and negative compression and tensile, and then you get the greatest value for tensile and compression stress, and then you solve this problem. So the classic example for chapter 5. And then we talk about the sectional moduli, and we know that the square is more efficient than circle with the same area. And of course, I shape will be the greatest one, the most efficient, most ideal one. And then we talk about the dam problem. Okay, the dam problem led us to analyze, to to guide us to learn how to. Thank you. How to let us know how to analyze the daily problem. Okay. Right. Thank you. So I don't need to shout now. And then we talk about the shape with the gradually increased cross-section area. Okay. And again, you need to have essential technique from chapter 4, and then you can you need to derive the dx because the area is changing, so the sectional moduli is also changing as well. So you can see this that they are all the function of x. Okay, and sigma x mix is mx divided by sx. The mx itself is also a function of x. Sx is a function of x, so you can just you just put that together. You can have the sigma mix x function. And now don't forget that it should have a positive and negative. Okay, because when you have a moment on this, this is a cross section. Okay, this is cross section, and because they are symmetry, right? They are a little bit symmetry, so C1 and C2 are the same, and sigma. So sigma B1 and sigma B2 are the same. Okay, so positive and negative, they are all the same. So sigma x mix actually describing sigma B1 and sigma B2. And one of it is positive, one of it is negative. All right. So okay, they are symmetry. So this is, we just obtained the formulation for entire being, entire material system. Okay, so now sigma B mix, easy. We substitute x equal to L, the B of course to the A, and then we can get sigma B mix is 4PL pi the A3. And of course, positive and negative, because up and down, the top and the bottom point has the same stress as and also they are maximum. One of them are positive, the other is negative. Okay, this is the first one. Let me rearrange a bit. Okay, and then next one, sorry, I'm going to write down the second one. Ugly. Okay, a second one, sigma mix. Okay, So sigma mix, you have the function for entire being, right? So all you need to do is trying to find the maxima for this function. What should we do? Differentiation, right? Differentiation and set it to the 0. Sigma mix function, x mix. So this is a function, and we need to set them 0. Zero, okay. So how can we do that? It's 32p, or it's a little bit tedious. dA plus dB minus dA. Wow. XL times XL minus 3 plus 32px pi minus 3 dA plus tedious dB minus dA times x divided by L divided by 2 minus 4 times, wow, times dB minus dA divided by L. Wow, very crowded. Okay, equal to 0. Okay, so x equal to half L. Wow, how can we solve that? Do you know how to solve that? I don't know. Maybe. I forgot. I forget how I solve this. Okay, I just write it down, and I believe maybe I can use the function of the calculator. Okay, you just type all this, and you set the x equal to half or 1/3 or 1/2. So you just try the x. You try the x, and then it will approach into 0, and then you can get the value. Do you understand what I mean? 你知道有一种技巧就是啊，哈，你用计算机，当然是要电子就工程计算机，应该大家都有吧？把它打下来，把这个式打下来，然后当然这些比 A 就是要怎么讲？对啊，因为底 B 跟底 B 是可以被消掉的。然后啊，那我就会把它整理好以后，打在式子上，打在 calculator 上，然后我就去试那个 x，我就去试这 x。例如说，我就会试，然后因为一定是几分之几 L 嘛，所以我可以把它这试成1/2，就0.5，那么就写0.5，因为 L 会跟 L 除掉，所以我就把所有 x 地方就例如说0.1、0.2、0.3等于0.4等于0.5，然后它就不等于0嘛。如果你不知道，你没有算到这个0.5的话，它就会不等于0，但你就会越来越接近，你知道吗？一直按狂按，然后你就一直 approaching，就是接近那个答案，你就可以得到这个答案，然后到最后答案哦等于0了，好，达到答案了。所以这叫做数值解 （numerical approach）。You're not actually solving this formula. Actually, you try all the answer by using your calculator, and then you can get the answer. So you can try that. I remember that at some point when I solving the problems in mechanics of material, I used the technology, the techniques I just told you. OK， 我曾经记得我曾经用过刚刚那个方法去解材料力学的答案啊，材料力学的题目，搞不好你们已经做过了啊，但是我忘记是什么时候的事情了。那搞不好就是这一题。好 ，OK， sigma mix equal to 1 to APL 27 pi dA3. Okay, so again, positive and negative 4.741 PL pi dA3. Okay, that's it. So you can see that even moment appear at the end because the cross-section area are changing. So the sectional moduli also changing. So you need to find if you want to find the maxima shear stress, maxima normal stress, you need to do the calculations. Okay, that's a little bit complicated. So that's the reason why I always said chapter 5 is always the most difficult chapter in mechanics of material. Okay, that's it. Rearrange. Wow, perfect. Okay, now next one. Next one will be even further to examine the thing. We now discussing the moment, right? And we talk about the normal stress due to the moment, caused by the moment. And then it compress the beam and tensile the beam. Now, how about shear? So you see the moment diagram, you use that. How about shear diagram? Next one, I will let you know how we use shear diagram to determine the shear in the beam. Okay, so that's it.我在想昨天有没有发生什么事情，好像昨天就是完全没有什么发生，没有发生任何事情。哦稍微有点小事情，就是我昨天带我小孩子去照护照的照片，然后我就想说，护照照片就去照相馆嘛，我就带他去照，然后我进去以后。然后我就说好，我要照护照，然后他就说好，里面还有一个人，下一位等一下，我就坐在那边。结果当我坐下以后，就开始瞬间来了4个人要照护照，2个人要照护照，2个人照护照，然后还另外在排在外面。我说哇，我就只差5分钟吧，我就会变成要等至少要1个小时。然后我觉得很奇怪，你有没有发现你有没有觉得你常常进到一个商店的时候，一开始都没有人，你进去，然后后来就然后就大爆满，有这种感觉吗？有哈，我也不知道为什么，我也有这种感觉。对，就是这是很神奇的一件事。Okay, so right, so next one, using shear diagram to help us to know the shear stress in beam of a rectangular cross-section section. Okay, rectangular. You see that we kind of limit our focus because the later proof are based on rectangular cross-section. All right, it won't fit other cross-section. Okay, because this is the easiest. Okay, now you see this is a side view. You see this is X, right? X. And of course, this is a Y. and Z toward you. Right? And so this is side view. Okay. Then imagine that this is a segment in a bin, and you have a V here, M here, and V plus dV and M plus dN, whatever the force on it. Okay, so we are going to see the shear on that surface, or sorry, maybe I change a bit. The shear on this surface, okay? This surface in the middle, right? The yellow part, okay? And I want to see the shear stress on that stress element, all right? So if I want to see that section, I cut it, right? I cut it. Now I cut it. So you see the yellow lines is actually the bottom left shape. You see? Good. All right. This one, this one, this one, this one. All right. Dot, 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 dot. All right. Okay. So now we are going to see the shear. However, I will let you know it will be really difficult to determine the shear by using this one. It's really difficult because you need to do the force balancing on this surface. This is really difficult, right? How about we change our plan? We did a detour, or the detour is easier. Okay, so we know that the shear is always appear in the group, in coupled, right? So don't you think, sorry. These two stress are the same, right? Or these four stress are the same, right? So we just say this is difficult. 太长了。Difficult. Okay, but this is simple. Okay, so it is easier for us to do the force balancing in horizontal direction than the vertical. So because of that, we are going to determine the simpler one, horizontal one, and once we obtain the value, we immediately get the tau in the vertical part. Okay, so we're now focusing on this one. We're now focusing on this one. Okay, and then because we are going to focusing on this one, I want to see the top surface stress on that element. So I believe you are going, you know what I'm going to do is that we cut this surface, well, this element, this region, to see the stress, the force on that surface. See, okay? 简单来讲就是垂直的很难 ，shear stress 垂直的很难算，但是反正它成对出现，我就算比较简单的，水平的比较简单水平的比较简单，所以我们就换，就是等下算水平的，算呢值出来了以后，反正他们都一样嘛，对不对那既然要算上面那个平面的 stress， 那我就把它切开来，我留上面，留那个粉红色的那一块。等一下，下一面就得到，那就力平衡上面那个就可以了。Okay, so if you get that, we just this is the stress. Wow, this is a region we cut, and the tau here is to the right. Did you see that? Left hand side and right, because they are the same the same surface. If they connect back together, they need to cancel each other, right? So this is left. So here is right, because you left the upper part. Okay, right. Then you know that this part is down due to the moment m plus the m, right? And this one is m, right? So these two stress are are due to the moment, and you know how to calculate that, right? We just taught that, and so all you need to do is sum them up. The stress times the area. Stress times the area become force. Stress times the area become force. And then you do the force balance. So I told you 95% of the proof in the mechanics of material is times the area, make the stress times area, and then you do the force balance. And here is the same. So left, this part, the sigma 1 equal to minus my divided by I, right? This is because this is down due to the m. And F1, of course, do the area integration. So this is the area, okay? So my, okay, right. So maybe you will see that why there's no minus signs here. It's okay. It's okay, because all we care is the force value. The force value, and then once we are going to do the force balance, we actually this minus is actually going to right direction. It's positive direction. So this is actually positive. Okay, so the reason why this is minus, because this is compression. But now total force, once you go into total force, you actually when you do the force balance, you use your sign convention in force balance. 好，这边我不是说，哎，这边是为什么是负的，然后这边就没有呢？因为这边是负的，是指说它是压力嘛，对不对？好，它压在这里，然后你的力做了面积分以后，变成一个真正的力了。OK，真正的力，它虽然是就是往右走啦，那当你在做力平衡的时候，你会有自己一个符号系统嘛，往右为正，往左为负，对不对？哈，所以反而等一下这边的负的，那做出来的 force 也是负的。OK，所以你可以发现，等一下你可以比较一下。Okay, so we can, if you have no problem for left hand side, we can write down right hand side. Sigma 2 equal to minus m plus dn y divided by I, and F2 equal to F2 equal to sigma 2 area integration minus m plus d m y I and dy dA, sorry, dA. Okay, you see that this minus and there's nothing here, and both of them are compression. So you notice that stress, yes, this is compression, All right, but when we are going to do the force balancing, all we need to care is the value of the magnitude of the force and the direction of the balancing system. Okay, minus positive, minus minus. So actually they are separate. You just need to get the value, and then you identify its sign by the direction. So now tau here, the tau here in the middle, tau is actually F3 tau dx b. Okay, b is the dx, sorry, dx, and this is b. All right. And again, I would like to emphasize that okay, so this is tau. This is tau, and actually what we are going to determine is this one. Okay, our target is this one, but now at this stage, we go for this. All right, because this is easier for us to do the force balance. 这样可以听得懂吗？好，平的比较简单，垂直的比较难。为了想要算垂直的，我们只好先算水平的。那水平的这边，反正左边的 stress 乘上它的面积，等一下算它的面积；右边等一下算它的面积。OK， 然后，对啊，然后就可以算。好 ，OK，next one。Right. So next one. Oh, again, this is a side view, please. This is a side view. Side view. Don't think they are cross-section view. What is cross-section? This one. This is cross-section. This is a side. So, okay. Now this is a side view, and cross-section is this one. Okay. Cross-section is this one. Okay, so this is really, you need to be really careful. Okay. You see here is X, right? So be really, really careful. Okay, next one. Let's continue. We have the force this one, force this one, force this one, left and middle and right. All we need to do is do force balancing. F3 plus F1 minus F2 equal 0. So you have F3 equal to F2 minus F1. Okay, so tau b dx equal to dm divided by I y dA. Hey, so this is the result, and we are going to draw further. So again, this is a side view, and then I'm going to give you a cross-section view on the right-hand side. Okay, so how to draw it. Again, green side is side view. Oh, sorry, green side is cross-section view, and the blue side is side view. Okay, so please be really, really careful. Okay. Right. Now, okay. So we are going to put this to the right. Okay, to the right, and it become tau equal to dm dx, and 1 divided by ib. Okay, here this one, and with the y dA integration. And you notice that dm over dn over dx is shear value, right? We obtained it in chapter 4. The slope of the m moment will be the shear value at that point. So we just substitute this as v divided by ib and y dA. Remember y dA? Do you remember y dA? What is y dA? Y dA is actually the first moment. Remember this v divided by ib. Remember the q. What is q? The first moment of the shaded area about the neutral axis. Remember the q, right? The q. Bear me a moment. Let me find where can we. What is the q? Ready? Go. This is q. Remember that? This is the q. The first moment of area. See, q, y, q, x. Okay? You learn that. All right? So I just q. Okay? So very important. The first moment of the shaded area about the neutral axis. What is the first moment? Okay, now the shaded moment, the green shaded the area, the moment about the neutral axis. What is the neutral axis? This one, right? And then the centroid of the green area times the area times this length. Okay, this is the definition of the Q. The area times its distance between the centroid and the neutral axis, the rotational axis, right? So the Q, don't worry, just the area number times this distance. That's it. Okay, don't think this is too difficult, but well, the process, the procedure is tedious, but the concept is okay. 好，这边蛮复杂，但是我觉得概念还好啦哈。就是说，我们在做完力平衡以后，我们就得到这个式子，然后我们把 b dx 移到右边去，就得到这个式子。好，然后 dm 除以 dx，那就是 moment 图的斜率啊，那不就是简力吗？好，替代掉以后，剩下 ib，接下来剩下这个 y 底 a 的积分，那似曾相识哈，它是 the first moment，也就是我刚刚请你们回去看前面几页的 q，这 q 什么意思呢？就是这个 area 对于它的旋转轴的分布情况，对不对哈？所以就是这个 area 的面积乘上它行星到中性轴的距离，就这样嘞。Q 就是这个面积乘上它的行星到中心轴的距离，就是这样。好，那所以啊，so when you have the shear diagram, you get V, and then you know where is the position that you're going to derive the shear stress. this height is y1. Okay, y1. So you need to determine the shaded area Q. OK， 所以说如果你要找到一个 shear stress 在这里，在 y1 的高度的话 ，y1 的高度的话，中性轴以上 y1 的高度的话，你就要把它以上的东西，当然以上或以下都可以了哈。那选比较小的那个 area 好不好？如果你今天取在这里，你就取下面，好吧？总之就是以上的那个 area 比较小的这个 area， 它的 Q 算出来，再除以它的 IB， 再乘上它 shear diagram 的那个值 B， 就可以得到这一个高度的 shear。OK， a little bit tedious, but I guess you can understand that. Right, so this is really important. So I give it several stars. Tau equal to VQ divided by IB. So now I transfer into cross-section view. Cross-section view, please. Y, Z. Okay, cross-section view, please. This is not side view. This is a side view, okay? This is a cross-section view, please. Very important. So now, you are going to obtain the shear stress at this line. And this line is above the neutral axis by y1, okay? y1 distance. And then, how to calculate that? All we need to do is calculate the Q, okay? The Q here. So Q is the area times the distance from the centroid of the area to the neutral axis. All right, so this one, okay, and that one and that one. All right, so here, let me take a look how to do that. B. Okay, so Q here is the area of the how to say how to do that? Green. Okay, green area. Q. Okay, the Q equal to B times this one. Okay, height, half height minus B1, obviously, right? And then, well, it looks terrible, but should be okay. It's actually this one and plus y1 plus this one. Okay, I hope the color won't. This one is actually this one. Okay, and y1 is just this one, and then you plus. Oh, okay. 啊，好难哦。This one, that one. I don't. If you cannot see the video, and then you'll never understand what I'm talking about. Okay. This is actually the half height of the ring area. All right. And then you got this one. Okay. I try my best to use in the color to let you know. All right. If you are colorblind, I'm sorry for that. But if you are colorblind, I believe, I bet you are a genius. All right. 哎，我遇到很多天才，我遇到很多色盲都是天才哦，真的，至少2个，而且是世界级的天才。所以不好意思啊，如果我的颜色没办法帮到你的话，你是色盲，但我相信应该没问题，你不需要我帮忙的。当然，如果你真的看不懂，然后你是色盲，你赶快告诉我，你可以下课来告诉我，我来帮你就是一一的比对。 All right, so that's it. Okay, and then you can get the tau here, the value of tau here. And you notice that because the y1 is the value, arbitrary value, can be this, that, or that, any point. So if you draw this v1, tau in the height, at the height, you notice that it is the parabola 抛物线, okay, 二次的 second order. So when you see this side view, okay, you see that the shear stress at this side should be small and getting greater and greater. In the middle, it getting the biggest one, and then getting smaller again. So it's a parabola, 抛物线. Okay, so maximum stress occurred at the neutral axis. All right, because well, just calculate that. And also y equal to half h, positive and negative, it becomes 0. See, nothing at the top, at the bottom for shear. Okay, so you see that this is exactly, well, it's completely opposite to the normal stress due to the moment. Due to the normal stress due to the moment has the maxima at the top, at the bottom, but shear stress completely inversed. Okay, right. So I hope you can understand what I'm talking about. I believe this is really important. This is really important. So now, after this, you can calculate everything, every problem in chapter 5. Congratulations. So limitation of this formula is because we focus on rectangular, right? Rectangular. So it actually doesn't fit other shape of the rectangular, other shape of the cross section, sorry. So the next one, shear limitation of shear formula. Of course, we assume linear elastic beam, just everything else, just like everything else. And also, because we assume that this one, the shear stress is uniform at a certain level, okay? And vertical to the neutral axis. So, so everything is something like that. So, okay, this is the everything I need to talk to you for this week. So I will continue our lecture in next week. Thank you. Okay. Right. So if you have any questions, just let me know. Come to the stage. Thank you.请问
哦，这个是乘3分之一，
三分之 h 是，我看一下，3分之 h，
这应该是里程。
这是30方吗？我看一下。 哦，没有啦，这个 mx 是当你画这个简律弯曲图的简历弯曲图的时候的弯曲，它的 mx 是这个值。
可是我要怎么知道？
你就画简历弯曲图啊，
这个
你画简历弯曲图，你画画看，你就可以得到这个值。哎
好，
哎，你画简历弯曲图。第4章的做法，试试看。而且s 我猜就是它的直角三角形的直心的坐标，1/3、1/3嘛。对。